Hey everyone, welcome back to my channel. Don't forget to click subscribe if you want everyday updates of my videos. So let's move on to the topic. Today we are going to learn about the trigonometrical identities. Trigonometrical identities. What is the trigonometrical identity means? So basically these are going to be equations which you have to memorize, and first of all we are going to see how all it came. So you may recall an equation is called an identity when it's true for all values of the variables involved. It means any equation for any kind of values, if the equation is true, so that is called identity. So similarly, an equation involving trigonometric ratios of an angle is called the trigonometrical identities. If it's true for all values of the angles involved. In this session, we will prove one trigonometric identity and use it further. So we are going to start up with a right angle triangle. So let's call this up with ABC. And the acute angle we are going to talk about is A angle. So in this triangle ABC, right angle at B. So we are going to use Pythagoras theorem, which is AB squared plus BC squared is equal to AC squared. So we are going to divide the whole equation with AC squared. So what we will get? We will get AB squared over AC squared plus BC squared over AC squared is equal to AC squared over AC squared. So we can write this one as AB over AC whole squared plus BC divided by AC whole squared, and this is going to be 1. So what is AB over AC? AB over AC is going to be cos A, right? Cos A is going to be adjacent over hypotenuse. So for cos A, AB is the adjacent, AC is hypotenuse, plus same like BC over AC is going to be sine, so it's squared, then sine squared A is equal to 1. So cos squared A plus sine squared A is equal to 1. So this is the first identity, first trigonometrical identity, we proved it. And the same equation, let's say this equation name is x. This x equation we are going to divide with AB squared instead of AC here. So divide with AB squared, and then let's see what we will get. So first AB squared over AB squared plus BC squared over AB squared is going to be AC squared over AB squared. So it's going to be 1 plus BC over AB whole squared is equal to AC over AB whole squared. So what is BC over AB? BC over AB is going to be tan A. So 1 plus tan squared A is equal to AC over AB. For A, acute angle, AC over AB. So it's like the hypotenuse over adjacent. So adjacent over hypotenuse is cos A. So hypotenuse over adjacent is other way around, which is 1 over cos A. So that is sec A. Sec A, which is squared. So this is the second identity. So cos squared A plus sin squared A is 1. And 1 plus tan squared A is equal to sec squared A. That is the second identical equation. So we are going to do the same. I mean, like the same x equation with divide this with bc squared, divide with bc squared, and what we'll get? ab squared over bc squared plus 1 bc squared over bc squared. This is 1. And then ac squared over bc squared. So AB over BC. AB over BC is going to be 1 over tan A, which is cot A, cot squared A, plus 1 is equal to AC over BC, which is AC over BC, AC over this one, AC over BC, which is 1 over sin A, which is cosec A. Cosec A. So cot squared A plus 1 is equal to cosec squared A. This is third equation. So basically we learned, so we'll write down the trigonometrical identity. Trigonometrical identity equation. So first one is sin squared A plus cos squared A is equal to 1. For any acute angle A, it's going to be true for all the values. If you put any A, any kind of angle, then it's true. So it will be 1. You can put A is equal to 30 degree, 60 degree, 90, minus 30, let's say like 150, 540, any value, this is going to be 1. And 1 plus tan squared A is equal to sec squared A. Or you can say like sec squared A, you put this one here in this section, sec squared A minus tan squared A is equal to 1. So this way, this looks better. So the third one is 1 plus cot squared A. So we put this cot squared A in this side. Cosec squared A minus cot squared A is equal to 1. So these are the three identical equations, trigonometrical identity. So let's move on to an example. Express the ratios. Express the ratios cos A, comma tan A, comma sec A in terms of sin A. So we are going to start up with the first identical equation, this equation. So we are going to express cosine A in terms of sin A. So we are going to use the first identical equation, which is sin squared A plus cos squared A is equal to 1. So if we put this one here, sin squared A is equal to 1 minus, sorry, it means other way around. You have to put this one outside, other side. So it means, so sin squared is going to come out this way because we're going to express cos A in terms of sin A, means in the right hand side sin A should come. So 1 minus sin squared A. So cos A is equal to 1 minus sin A root. So this one, sine squared A. So cos A is equal to root of 1 minus sine squared A. Then tan A. Tan A is sine A over cosine A. So in terms of sine A means we have to make the cosine A also in terms of sine A. So sine A over cosine A we already found it here. So 1 minus sine squared A root. So that is done. And sec A means 1 over cos A. So instead of cos A we'll put 1 minus sine squared A root. So another example, we look at another example. Prove that sec A into 1 minus sine A sec A plus tan A is equal to 1. So we are going to take the left hand side. So left hand side. So we're going to simplify this. In this case, I'm going to make everything into one format. So cosine sine better. So sec A, I'm going to change this to 1 over cos A for an easy calculation. So let this one be as it is, 1 minus sine A. Sec A again is going to be 1 over cos A. Then tan A is going to be sine A divided by cos A. So let's see what happens. So you can, this one is, so on the top 1 minus sine A, and if you take this one as common in the down as a denominator, so it's going to come up like this, sine A over cos A. So 1 minus sine A, 1 plus sine A. It's like A squared minus B squared is equal to A plus B times A minus B. So if this is the case, so this is the case should come. So 1 squared minus sine squared A. So 1 squared is 1 minus sine squared A over cos into cos squared A. 1 minus sine squared A is cos squared A. Why? Because sine squared A plus cos squared A is equal to 1. So this is the first trigonometrical identity. So cos squared A is going to be equal to 1 minus sine squared A. So cos squared A divided by cos squared A, which is 1. This is right hand side. So it's proved. This one is proved. And we'll prove another example. Prove, all these are proof questions. Prove that sine theta minus cos theta plus 1 over sine theta plus cos theta minus 1 is equal to 1 over sec theta minus tan theta. Using the identity, you're going to prove this one using the identity. Sec squared theta minus is equal to 1 plus tan squared theta. The second identity, we are going to use it to prove this one. So start up with this LHS. Start up with the left hand side. Left hand side is equal to, so what I'm going to do here is we're going to create sec theta or sine sec theta and tan theta here, because everything is in sine and cosine in the left hand side. So what I'm going to do is I'm going to divide the numerator and the denominator, I mean the upper and the lower part, with cosine. So I'm going to divide with cosine theta. So sine theta, so each and every element will be divide with cosine. So cos theta divided by cos theta plus 1 over cos theta. And it's going to, because it doesn't change anything, because if you divide any ratio with up and down the same value, the ratio is not going to change. So by using that logical formula, so we are going to use it. Sin theta over cos theta plus cos theta divided by cos theta minus 1 over cos theta. So sin theta over cos theta is tan theta. That's why we created this, because RHS and everything is in the tan and the sec. So minus 1 plus 1 over cos is sec theta. So tan theta plus 1 minus sec theta. So how you're going to create from this to this. So this part is only, it's little different. It's 1 over sec theta minus tan theta or something. Okay, so what I'm going to do here is like, it's a little tricky. I'm going to, arrange this equation in a different way. I'm going to arrange this equation in a different way. So I'm going to take the tan and the sec close by. Tan theta plus sec theta minus 1 over tan theta minus sec theta plus 1. It doesn't change anything. You just put this one closer to tan theta. That's it. Why? Because I'm going to adjust this equation to create something on the bottom that is demanded in the RHS. So actually I'm gonna, tan theta plus sec theta minus 1 on the bottom, tan theta minus sec theta plus 1. So what I'm going to do, I'm going to create that. I'm going to multiply the up and down with tan theta minus sec theta. Let's see what will happen, because there is nothing coming up like sec theta minus tan theta on the bottom. So I'm going to create it. I'm going to create it. Actually, I created this one. If you want to create this one, you have to do the same thing on the top as well, because it should not change the whole value of the equation. So that's why I instead of multiply sec theta minus tan theta, why I multiply with other way around is I can do something. I'm thinking like it's just a hint. I mean, it's just mind thinking that it will work. Sometimes it doesn't work. So if it doesn't work, you have to think in another way. You have to cut the thing and you have to do it in another way. Just check what will happen if I multiply with tan theta minus sec theta. So actually in this case you can write this one on the top. It's going to be tan squared theta minus sec squared theta. Something is happening, right? So for the simplification, something is happening. So that's why. So it's like this one. Why? Because this one, a plus b, a minus b. So a squared minus b squared is equal to a plus b times a minus b. That's why we are using here. So minus 1 times this. So it's going to be tan theta minus sec theta. And this one into, so let's don't do anything on the bottom. Because why? Because this one is needed. This one needed in the RHS. So let it be as it is and simplify on the top, and let's do something. Let's see if this one is going or not, because if this one goes, our work is simple. I mean, what I'm telling is, if I get -1 on the top, if I simplify this and get -1 on the top, minus of this, this one will get the other way around and the answer is coming. So let's simplify on the top. What you will get, tan squared theta minus sec squared theta. So tan squared theta minus sec squared theta, this one. So if you use this identity, so tan squared theta minus sec squared theta is, the sec squared will come this side, 1 will go this side, so -1. So I'll put this one as -1 minus tan theta minus times minus plus 6 theta. So tan theta minus sec theta plus 1 tan theta minus sec theta on the bottom. So this one and this one cancel, and you can put -1 over up. Why? Because this is the top of the bottom one is the minus of the upper one. So you put the -1 up and cancel all those things, because same thing on the top and the bottom you can cancel. So -1 means you can change the place of this other way around. So 1 over sec theta minus tan theta. So this is RHS proved.